Yeah, online students, is my voice is loud and clear? Everyone, please confirm. Okay, done, guys. So in the last class, we have completed the theoretical part of LSTM. One minute. Okay, done. Sorry. Okay, guys. So in the last class, we are discussing this LSTM code now. That is, theoretical part of LSTM was completed. Now in today's class, we are going to move on to the coding part of LSTM. Now, after the coding part of LSTM, and we'll continue from here with the, as already I have completed for you the NLP. Now in the NLP, we have completed for cross-sectional data, that is non-sequential order of records. Now we are going to combine the NLP with LSTM. A combination of LSTM and NLP only is called as our generative AI concept. Okay. Yeah. So now we are going to see the coding part for RNN with LSTM. Now, what are the RNN code is there now? For RNN, there is no separate code or there is no real-time usage for the RNN. Okay, as we are going to use the only LSTM in the reality, because there is no use of the short-term memories. Okay, always we work on the long-term memories only. So since there is no use of RNN, that is initial concept of what is the use. But later, if you come to the later part, we are going to work with the LSTM only in the reality. So all the works models will work only with the LSTM, right? Now, coming to this, the next one is yeah. Now, here, what are the work we are going to do? That is today's RNN or LSTM work, whatever we are going to do. Please focus on this code. This code is comparatively different with the remaining algorithms like CNN or ANN. ANN is a different code, CNN is a different code, RNN is a different code. There will be no connection between the codes. Whereas in the machine learning algorithms, everything are connected to each other. Like simply we can import them and directly we can fit on the data. But coming to these kind of codes, they are not having any kind of connections. Okay. Now here we are having the data. What are the data I'm going to work today in this class? The data is related to train data and test data. One is train data, second one is test data. Now train and test, what are we are having? So they have given already the train, they have separated the data. For example, if they have not separated, in the case of non-separation, in that case, what you have to do is after loading the data, first step you have to separate the data. Before processing on anything, first you have to separate the data, train and test. How you are going to separate the data, train and test means by taking the initial 80% of the records. So first 80 records. First 80% of the data has to be selected as train data, df underscore train. And next 20% of the data, whatever you are having, that should be selected under the df underscore test. Okay. So how you are going to select first 80% of the data under this one means you should not apply the train test split here. You should not apply the train test split here. What is the data you have to apply here means first for the this train instead of applying the train test split, you have to go with the ilog. And you have to select the initial records. So for example, they have given the 2000 records they have given to us. First, you have to multiply 2000 into 0.8. What is 2000 into 0.8 means 1600. So here you can write the 1600 records with all the columns. So 0 to 1600. 0 to 16 means first 1600s will be selected from here. And df.ilog of 1600 to remaining. These are the rows along with all the columns. Okay. So first 1600 we are going to select here. That is we are going to write in the df of train. And second this we are going to consider in the df of test. So like this we are going to separate the data. df of train and df of test. Right. Now after separating the data like this. Okay, then only we have to proceed to the further everything. Now in this case, I already have received the data and what are the data I have received and what is the business problem. These both we are going to see in the one by one. Now the business problem along with the data, what I have received. Here I am having the data. Yes. You mean we have to explicitly split the data, train test split instead of using the random selection because sequential order of records are important for us. We cannot go in the non-sequential order. So now here it is related to one of the stock market related data set where we are having in this data set where we are having the values like this. So for example, here I am having the one date. What are the data I am having? 2012 January 3rd. So here 01 indicates January month. This is as per the US format. Okay, month, date and year. So now what are the US format we are having here? The dates. I'm having the dates. Okay. Now, first, before asking the questions, please give me some time, online students, so that you'll understand the things. Dilip, before typing the question, wait for another 5 minutes. First, let me explain. After that, you can ask the questions. Okay. First explanation, later doubts. Instead of doubts and later explanation, it will not be correct. Okay. First, let me explain. Now here the data, what are the business problem they have given to me is I have to estimate the stock price for the next 1 month or something like this. I have to estimate the stock price for the 1 month data or something, right? Now this is the work they have given to us. Now estimate the 1 month stock price. Now for 1 month, what are the stock price we are going to estimate? What I have done is the last 1 month, what are the 1 month data I have separated and I am assuming it as a test data. Now here for me, original data is there Now I'm going to predict my what are the y predict will be there now. We are going to predict that one, and here our values will come. So we are going to compare with the original values versus predicted values, and we are going to observe the difference. Now, what are the RMSC we are having in the train RMSC? And for this 1 month, whether we have predicted in a right way or not, we are going to cross check by using that test RMSC, train RMSC and test RMSC, right? Now, so here we are having this data. Now here the data is from January 2012 to the data till what data they have given to us, miss? The data is till December 2016. So this one they have given, and they are asking us to estimate the 1 hour price. 1 month price. So we have to estimate the 1 month price. So what I have done, last 1 month I have separated as the testing. Remaining things I have considered as training. So now what are the training we are going to observe, and just we are going to estimate on the test data. Okay. Now, so here we are going to calculate the for 1 month or something like this, or you can even take the 80:20. Now here, sir, date column was there, miss. Now it is called as sequential data. Can we fix like this, miss? No, we cannot fix the date based on this one. For example, in the hospital also, we will have the patient records along with the date. Date and whether the patient is having the cancer or not. Yes or no. Yes or no, this is the output. We have to predict whether the person is having the cancer based on the other parameters. And we are also having one of the column is called as date column, on which the person has taken the test. Okay. For example, the person has taken the test on 1st 2026. January 1st, 2026, he has taken the test and he is having the cancer. On 5th, another patient has taken the cancer test and he is not having the cancer. Miss, whether it is dependent on the date column? Cancer is dependent on the date column, miss? No. Here it is not dependent on the date column. On which date the person has done the test, it is not dependent. It is dependent on other features. Here what we are going to do, though the date column was given to us also, we are going to remove simply. In the cancer data set, whether the person has cancer or not, that is a business problem. For that business problem, date column is not unimportant. It is not important for us. For example, for example, one more person is there. He has done the test on the 12th, 2026 and he is not having no cancer. Instead of 12th, he has done on the 2nd. If I bring this record on the top, anything changes? Anything changes or not? Yes or no, miss? It is not going to change anything. So, for example, see, according to you, okay, for example, everyone knows COVID now. Cancer may not be familiar. Okay, COVID at least you know now. For COVID, for example, I am having here body pains. One is body pains. Whether the person is having the body pains, yes or no, something. And the second one is like a headache or fever or warm things, something. Okay, these are the parameters. Along with the COVID test, some test result. What are the COVID test result is there? Some test they will conduct now. Now, based on these parameters, we have to say that whether the person is having the COVID or not. Sometimes COVID test will give the negative, but still the symptoms will be related to COVID. Okay, so we have to estimate based on the parameters, we have to predict whether the person is having the COVID or not. In that, one of the column is date column. For example, date we are having like this, 01/01/2026. And one more person is having on 10th/01/2026. And another person is having on another date. Like that we are having. Now, if I bring this another person who has done the test on 20th/01/2026, if I bring this record, for example, this is the record now. If I copy this record and if I bring onto the top, if I change the order of this one, is that it is going to impact? Date is going to impact, or order of the records is going to impact? Order of the records are important or not important for this data? For this particular business problem, whether order of the records are important or not important means order of the records are not important. When order of the records are not important, then automatically the date column will become as unimportant column and we are going to remove it during the data cleaning. In the data cleaning process, we are going to remove it. So it's all depends on the business problem. For the given business problem, first we have to observe sequential order of the records are important. Sequential order of the records are not important. That one we have to observe. That is the first one which we have to observe. Whether sequential order is important or non-sequential order. Right? Now, so here, what are the sequential order of the records we have received? Now, this is the stock market data set which I have received. For example, if I bring the 2012, 2013 up to 2016 is there. Now, if I bring this record, copy, and if I bring this record into this position, if I bring this record into this position and I am inserting the copied records here, and if I remove the date column, is that correct? Means one day the stock will open at 300 and it will go to 554. Again, it will fall to 330. Yeah? Point is clear? So here you have to understand whether the data set consists of date column or non-date column or not. We have to understand the order of the records are important or not. That you will understand based on the business problem. So once you understand the business problem, order of the records are important or not, from that you are going to conclude the remaining things. Is the point is clear, guys? Everyone? Understood? Now here I am having the data. Now what are the data is there? It is a stock market data, and where I am having the order of the records are important for me. So since order of the records are important for me, now I have to apply only the sequential algorithm related algorithm. If, for example, order of the records are not important for me, I can bring before or after or wherever I want. Then in that case, I'm going to apply the ANN. If the order of the records are important, means I have to apply RNN and LSTM. Point is clear? Now, this is first step. So since order of the records are important for my business problem, so here I have to apply only RNN or LSTM. Now, second, here first I'm going to load the data. Now, what are the data I have received? I'm going to load the data here. After loading the data, now these many columns are there. But in the time series, whenever you are working with the sequential order of the data, you are going to predict any one value, either the open price or the closing price. You will not predict the high price. For example, if you predict the high price, assume you have predicted for example, Infosys is there, Infosys company. Assume the Infosys share value is 1500 rupees. Let's take an example. I also don't know what is the exact value. Example I'm writing. Now, if I predict tomorrow, it will go up to 1550. Okay. Now, since I have predicted 1550, what you will do? You will wait for up to 1550. Now, tomorrow morning, it has went up to 1540. Tomorrow morning, it has went to 1540. And again, it has came back. Now, what you are going to say? Sir, 1550 you have told, but it has touched only the 1540 or something. And it is going to be a problem. So, instead of that, if I take any one column like opening price or closing price, any one column you have to consider. Either open or close. We are going to estimate the opening prices or closing prices. Sir, what is this opening price, closing price, high price, low price? Means in a stock market, okay, whenever there is a trading, means whenever the market opens at morning 9:15 as per the Indian market I'm writing, but Google is not the part of Indian market, it is US market. And here what are the value you are seeing? It is in the dollars. Okay, it is a Google stock price. Whatever we are working is in the Google stock price, and that too it is the US market. Now, so here we are having the stock market timing is 9:15 to 3:30. Exactly at 9:15, what are the prices there? Exactly at the 9:15, it is called as open price. Exactly at 3:30, what are the prices there? It is called as close price. In between, it will fluctuate to upside, downside, fluctuate upside, downside. Overall, in a day from 9:30 to 9:15 to 3:30, in a day, what are the highest value it will reach? It is called as high. What are the lowest value it will reach? It is called as low. Is the point is clear? Now everyone is clear with the column names. Data understanding is clear, guys. Date means on which date was traded. Next, opening price. Opening price means at what price it has opened. On that day, what is the maximum value it has went? On the same day, what is the minimum value it has got? and this is volume. Volume is how much amount of quantity was traded. Okay, total number of shares got traded on that particular day. Okay, now based on this, now here when I'm going to explain this one, okay, here most importantly I want to add one point, and which the students has to make a note of this one 100%. Okay, whenever I'm working with the stock market data, whenever, remember, we are going to work with the stock market or cryptocurrency or gold or silver prices, gold and silver prices. For all these things, the common point, what I'm going to write is more important. Now, based on this, based on our work, can we do the investment? Can we do investment? That is the question. The answer is simple, straight answer is very clear. Answer is no. Don't do. Why, sir? Miss, what are the analysis we are doing is not correct, or accuracy is not the perfect, or what is the problem, miss? Here it is going to have the multiple parameters. In that, one of the some parameters I'm going to explain, but after my project, today's project, some of the students, like experienced students and who are having the money with them and who are already doing some investments in the stock market, surely they are going to try this one, and they are going to think that based on this they can do the investment and they can get the profit. If that is the case, and every day I can estimate what would be the stock market prices, because I'm going to teach you now. Obviously, I also know this algorithm now. If I know properly and if I'm able to predict the stock market prices, surely I will not be in front of you. That is for clear now. Today I will not be in that teaching position for you now. Surely I will be in the somewhere, and I will also do that same stock market, and I will do my business, right? I'm sitting in front of you, and why I have to teach for you? Morning to evening, I can do that these things only, and I can invest and I can get the monies now. Okay, so based on our simple point, based on our work, can we do the trading? Not investment, trading. Can we do the trading based on this, miss? Answer is no. Straightforward answer is no. Because reason I will tell you, the reason behind this. Reason is remaining all projects. How many projects are there in the world? Remaining all projects, okay, depends only on data. But whereas stock market will not only depend on data, it also depends on news. Every day the news will change. What are the news is getting changed every day now? Those softwares will never be perfect. For example, ChatGPT has taken yesterday one data, and based on that it is predicting today. Suddenly new information ChatGPT has received. Tomorrow again new information ChatGPT is getting received, means ChatGPT will be a failure software. Since the data with the ChatGPT is a constant data and it is a fixed data, it is not changing the data. So that is the reason it is having the good amount of accuracy. But stock market will not depend only on the data. It depends on the news, and it also depends on the human emotions. Okay. Particularly today, the Trump will say that India is my friend. Tomorrow he will say that India is my enemy. Whenever he says India is my friend, automatically stock market increases, assuming that business with the US will be nice and something. Suddenly that day when the Trump says that India is my not friend and he is doing everything against to us US, if something he says against something means, suddenly everyone will think that, okay, business will not be there. Since Trump is not satisfied, he is going to impose a tariff or he is going to bring the new rules or set of regulations, and automatically everything changes and something, again stock market falls. Best example is yesterday and today. Yesterday, what are the we are having in the market yesterday? What is yesterday? Means Sunday. Sunday, we are having the stock market, and there is some kind of budget. Okay, due to the budget, suddenly the stock market has crashed. One day before, Infosys is a good company, but on the budget day, Infosys is a bad company. Suddenly, till that, Infosys is a good company. But in the budget, Nirmala Sitharaman says something against ITVs, suddenly it will become a bad company. And in the entire world, Infosys is only the bad company. In such a way, they'll sell off. They will not think about the fundamentals. They'll not think about the what is the companies and what is the future and what type of projects they are working as of now in the company. Nothing. Why? Because stock market will be involved with the human emotions, and some people in the market, they will not think about anything. Blindly they will do. For example, one of my friend, if he says that Array, silver is going to increase, means he will invest. He will not ask what is the reason. He will not even ask the reason. Invest. Because they don't want the logics. They want only the profits. What is the logic behind that? How it is working and what criteria it gives? Earlier, what happened earlier in the same way? Only this time only silver is having this kind of euphoria, or earlier also we are having this kind of euphoria. He don't want anything. What they want? Today, how much I have to invest? Tomorrow, how much I will get? This set. That kind of people are involved in this type of project. But in the ChatGPT, that type of people are not involved. In the ChatGPT project, or if you take the sentiment analysis project or something other project, this type of people are not involved. For example, we have to predict the wind energy. Wind energy will depend on the human emotions, sir. It will not depend on the human emotions. Wind energy will depend on the trumpetation. It will not depend on the trumpetation. It will depend on the weather conditions. But here, it depends on the multiple parameters. So that is the reason, never invest based on the algorithms. Sir, assume there is no news. No news, nothing. No human emotions. Everything is flat. Means outside market is neutral. In that case, it is going to work. Means high probability is that it will success. High probability, your algorithm will be giving the wonderful result, and your investment also will give the wonderful result. But some news comes, means everything vanish. Your entire work is zero. Right? For example, from last 3 months, 4 months, you have observed so many companies, and which company is best, that one, this one you have analyzed. And finally, you have decided these are the companies where I have to invest, and you decided something. Suddenly, Trump has told that I'm declaring a war on the India. What happens, your entire analysis of 4 months is thrown into the dustbin. Simply. Okay. Point is clear now. So it always depends on the news and all these things. When the multiple people involved in the project, finally it will be the worst one. Okay. So very limited number of people involved, then only everything will be good. Otherwise, what happen? Every person will say one opinion. Never ending process, that is. Okay. Even in the election also, election includes in India, how much of public is there? Every public they'll involve. Now, if you take the public opinion, every public opinion, individual public opinion, what happens? None of the person will become the prime minister in the never. Never. Simply they will go with the voting. At least one person extra is there also. For example, out of 3,42,000 or 3,40,000, even 1,62,000 people, or 1,70,000 of one category, 1,69,999 of one, 1,70,000 one. Exactly 50-50 is there also. This person is called as MLA. But in that area, these many people are against. That we don't want. Finally, he is MLA. Now, but in the stock market, it's not like that. Every person involvement will be there. Directly, whatever they feel, they will do that. Whether it is correct or wrong, they will not even think also sometimes. Right? Is the point is clear, guys? So please don't do the investments based on your work of cryptocurrency or gold or silver prices or stock market analysis using the ML and AI. Ask the ChatGPT. ChatGPT is powerful and it is having the huge amount of data and it was developed by OpenAI company and so much of powerful software now. Ask ChatGPT what will be the tomorrow's Infosys share price. Ask ChatGPT. It is a powerful software, right? If you feel it is a powerful, ask ChatGPT directly. What would be the Infosys share price? I'm saying example Infosys. What are the company name you are interested? Ask. Or silver. What would be the silver price tomorrow? ChatGPT also will give one number. That number will not be available tomorrow if some news is there. Okay? Points are clear now, everyone? Why I'm saying this one very clearly? Reason is clear, guys, everyone? Now, so please don't do the investment based on your AI or ML work on the stock market. Just to have an idea, we are working on this. In the industry, once, for example, in the real-time interviews also, if they ask you, are you having any idea on the investment domain or have you worked on any kind of, nowadays silver prices are increasing or cryptocurrency prices are increasing. Can you predict that one, miss? You can say the answer directly like this. Yes, we can do the some kind of estimation using the ML and AI algorithms, but right decision cannot be taken based on the output because it also depends on the other parameters. You have to involve the multiple other parameters also and you have to take the decision. What is the news? What is the geopolitics as of now? And what is the fundamentals and how the outlook of this? So like this, multiple parameters will be there for that, which generally the mutual fund investors or big investors who are having a complete grip on the stock market, they will do this one. A normal general person like you and like me should do the investment but should not do the trading. Okay, investment is different, trading is different. I'm saying trading. We should not do the trading, right? Trading means what? Buying the something and selling the same thing within the short term of time, like in the 1 week or 10 days or 1 month, within a short time. We want the profits in a short time. That we call it as trading. Investment means believing in one company and investing in that company and growing according to the company, like investment for 1 year or 2 years or 10 years or something. That is investment. Sir, investments can we do based on this stock market analysis? Means investment analysis is different. Investment is not ML or AI because investment requires the descriptive analytics. That is not this one. It is a descriptive analytics project. Okay, trading is a predictive analytics project. Both are different. Points are clear, guys, everyone? Now, coming back to this, what are the data I'm having here? Here I'm going to consider only the column name is called as open price, a single column called as open price, and I'm going to get the values like this. Using these values, I'm going to estimate the next value. Now, this is Excel sheet, as most of you are commonly familiar with the Excel. Just I'm trying to show you here. Now, see here, if I take here 1, 4, 7, 10. If I scroll down, what would be the next number? What would be the next number? Everyone knows sequence, right? In your aptitude, you know the sequence. What would be the next number, miss? 13. So Excel is going to give the based on the above 4 values. You have to set all the 4 values. Then you have to drag this one. Okay. Now if I give here 1, 5, 8, 14. Now can anyone tell me what would be the next value? Is there any relation? No. Which is not visible for us. There is no relation. But when I take the Excel sheet, these 4 values, and if I scroll down, automatically I'm going to get one number. Sir, what is this number? This is called as auto-regressive model. Basically, it applies the regression on the 4 values, and it is going to give the output. Now, instead of selecting the 4 values, if you have selected 3 values, then according to that, the output will be different. If you have selected 2 values, then according to that, the value will be different. So based on what are the number of values you have selected earlier, From that, it is going to, for example, here I'm writing the 0 or here I'll write the 10. Now from here to here, based on this, see the value was changed to 12.9. So now in the Excel, whatever it is doing now, auto-regressive model. It is auto-regressive model basically. Sir, what is this auto-regressive? You'll understand in the ML classes. During the ML classes, you'll understand that. But point is, just we are going to take the values and only these values we are going to use for the prediction. Now in our RNN model or anything, as I've told you, input will be the single value. Always the input will be the single value. So now here I'm going to consider the single column and this will be my input for the first neuron. This is going to be the input for my second neuron. Like that, it is going to be the input, one after input. Is the points are clear? Everyone? Yes or no, guys? Please come for me. Now, so what are the, here we are having one single column. Now I'm going to apply the min-max scalar. Why? Why we have to apply the min-max scalar? Miss, the reason is very simple. Since our LSTM model was designed based on the values between 0 to 1. All the values of input should be only 0 to 1. And the sigmoid value is also 0 to 1. Tan H function also will give -1 to +1. So the entire algorithm of LSTM is working between the 0 to 1. So that is the reason here we are going to apply the min-max scalar. So we are going to apply the min-max scalar. Now within this min-max scalar, what are the min-max scalar we are going to apply? Now here we are having the training set. What are the training set is there? So after applying the min-max scalar, now these are the values. Sir, okay, this is the values fine. But when we are going to predict the output, output also will be predicted between 0 to 1 only, na? In the same way. Point is clear. What is min-max scalar? X minus X min divided by X max minus X min. So in this entire data, what are the maximum value is there? Maximum value. What are the minimum value is there? That is going to be minimum value. Each value minus minimum value divided by that one. And you are going to get the 0 to 1. All the values will be 0 to 1. For example, assume the minimum value is 300. The maximum value is 800 and 300. Right? Automatically, here the first value order is there. That value we are going to substitute and we are going to get the first output. Second value will substitute and second one. Third value will substitute third one. Now, okay, sir. But for example, we are going to estimate for the future. Na? The test data also will estimate. There we have got the answer as 0.9. Now, wipe rate also will be between 0 to 1 only, right? So now whenever, when we are going to predict, if the wipe rate value here is going to be 0.9, original value is 778 and predicted value is 0.9. It is going to be a problem, no, sir. Automatically, both should be in the same range. Na? Now, see, again, we are going to convert this one, X minus X min divided by X max minus X min. Now, from this, we are going to now calculate the X value. Earlier, we calculated the scaled value. Now, we are going to calculate the original value. Now, X is like this only, 300 minus, maximum value is going to be 800 minus 300. This is 0.9. So, now automatically X minus 300 divided by 500 into 0.9. Now, X is going to be 0.9 into 500 plus 300. That is 450 plus 300, which is equal to 750. So here it is 0.9 means literally equal to 750. So from where you got that 750 means like this. Now this 750 will be compared with the 778. Point is clear? So converting from the scaled value to original value is called as inverse transform. Okay, converting. What are the original values there? Converting original value converting original value to scaled value, okay, is called as scaling. Now, same way, converting the scaled value to original value. Scaled value to original value is called as inverse transform. So, inverse scaling. If you have x value, if you are having x value with us, we are going to calculate the scaled value because remaining things are fixed. Remaining things we cannot change. X max, x min we can't change. These are all the fixed values. If you have this value, you will get this value. If you are having this value, you will get this value. Okay, one is available means opposite you will get. Point is clear? One is called as transform and one is called as inverse transform. Clear guys? Understood or not? Yes or no? Right? Now, coming back. So here, first I am going to apply the fit and transform. What is fit means? Calculate the x min, calculate the x max. Fit means calculate x min, x max. Transform means convert every value to the corresponding scaled value. Take some x value, convert to scale. Take x value, convert to scale. Like that. Right? Now it is going to convert like this. After converting, now here I am going to do this step is one of the important step. What is this step is? Because my LSTM neuron or RNN requires the previous input also, previous output. What are the previous output is that one also required along with the new input. Right? Two inputs it has to take. Now in order to get that previous output, what we are going to do is I'm going to divide some records. Some 20 records I'm going to separate. Other than 20 records, remaining things I'm going to consider. First 20 records I'm considering for the previous. And that data will be given and from there remaining things I'm going to add. So I'm just separating the 20 records and remaining things I'm going to consider. Now here, first I'm going to take the sequential. Sequential already we know. What is the order of the layers of neurons we are going to write? It has to take in the same order. Automatically the first one is going to be the input. Last one is going to be the output. And dense. What is meant by dense means? It is going to connect between the neurons to neuron. Connections. Next LSTM. What is meant by LSTM is? LSTM neuron you are going to take. If you remember here in the ANN code, we have taken the first regressor is equal to sequential. What are the model? And add where we are going to add in terms of denser, that is ANN neurons. If you don't write particularly LSTM, by default it will take the artificial neurons. Okay, since I have written that here LSTM, so now what type of neurons will be considered? LSTM neurons will be considered. So two inputs will be coming and two outputs you are going to get like this. This type of neurons will be considered. Return sequence is equal to true. What is meant by return sequence is equal to means what are the output of this one? Is there none? It has to be given to the next one. It has to continue the flow. Everyone is clear, guys? Now, question number 1 starts here. Sir, first question. Okay. Now, why we have to consider 20 records? I have taken as an example, first 20 records I am separating. You can consider 20 records, you can consider 30 records. Like, say, how many records they asked me to estimate? 1 month. So, 1 month they asked to estimate. So, what I'm going to do is, first 1 month I have separated. 1 month means how many days will be there? 30 days. But as per the stock market, 1 month means 20 days only. Because Saturdays, Sundays will not be available. So, here if you observe, in my data set, what are they have provided for me? The train data. Okay, in this I have separated the January month. What are the January month is there? So January month consists of how many records? So these records I have separated separately. Since they asked to estimate for 1 month, so I have separated 1 month. They asked for 2 months means I may separate 2 months. At the same time, too much of things we are not going to separate. Maximum up to 60 records. That is the maximum. Okay. Now here I have taken the 20 records and I have separated the data. After the question is clear, why I have to separate 20 records is clear now. Second, first I am going to take the LSTM layer. In this layer, I am going to add the 15 neurons. I am going to add 15 neurons. Sir, how to know it is 15 neurons only? Is there any fixed value, something like that? Miss, there is nothing fixed rule or something. Just I have started with the 15 neurons as my one layer. First I will take as one layer and I have completed my first model, model 1. In my model 1, I am not even having the LSTM of 15 neurons. What are the LSTM of 15 neurons is there? I have taken off only one layer and I have completed the entire project also. That is evaluation also I have completed. And I calculated the train test. Both of them I have calculated. Evaluation also completed. This is my model 1. Modeling plus evaluation was completed. In my model 1, how many layers I have considered? Only one layer. How many units I have taken? 50. Is that 50 is fixed or a random number? Miss, my random number. It is not a fixed value. Now what I have done? I have chosen the second model, model number 2. Okay, model number 2. In my model number 2, instead of considering only 15 neurons, what I have done is I have added the 100 neurons. 100. Okay. And again, I have evaluated train accuracy, test accuracy. Still, one layer only is there. No multiple layers. Only one layer is there. Added the train accuracy, test accuracy, calculated. Now, when I have calculated this one, now I got some result. When compared to this one, this result is there. Now, I am going to take the model 3. My model 3. In the model 3, what I have done is, instead of adding in one layer only 15 neurons, why I can't take the two layers separately? In the two layers, first layer consists of LSTM of 50 units in the layer 1. This is layer 1. In the second layer, I have added the LSTM of 50 units. Again 50 units. First one is 50 units. Second one is 50 units. Sir, now what is the difference? Here in the second model, you have taken finally LSTM one layer also 100 units. No, miss, total number of neurons are how many? 100 only. Here how many neurons? 100 only. Then what is the difference, sir? Here in one layer only 100 units are there. Here two layers of 100 units are there. Now I am going to observe again. Train accuracy, test accuracy. I am observing. Now, when I have observed, if there is no difference between both of them, assume there is no difference, then considering one layer is better or two layers is better means one layer only is better. Why unnecessarily writing extra one line of code also? Waste of time. For example, my model 3 has given the better accuracy when compared to model 2. Same 100 neurons only, but by splitting in the two layers, I got the more accuracy. Now in this case, which one I have to consider? First concept or second concept? So adding the layers is going to give the more accuracy. I have understood. Now tell me, model 4, what are the model 4 next model I am going to have? Should I increase the layer or should I increase the units? Which one is best option? Increase the layers. Layers with the 50 units or something. Now what I have done is, I have taken the model 3. My model 4. Okay, with 3 layers. Now how many layers are there? 3 layers are there. This is my model 4. And here again I have added the LSTM of 50 units with the layer 3. Now again I have evaluated. Train accuracy, test accuracy. Accuracies or whatever we call it as RMSs, I have calculated. Now I have got the better result here. Now what we have to do? Automatically I have to add the one more layer. Sir, the same thing why you can't do in front of us, sir? By adding first layer and calculating the accuracy, adding the second layer, calculating the accuracy, adding that one more layer, calculating the accuracy. You can do in front of us, no sir, in the class only, miss. This is not called as lab. If you want, I can do. If you want, I can do. Now for doing this one and executing everything, it will take for me 4 hours. 4 hours means 3 classes. Today I will complete the code. Tomorrow also same code. Day after tomorrow also same code. And after that also same code. Next 3 classes also I will work on the same code only. One day, one model I will try. In front of you, I will try all the models, like adding the one layer, deleting one layer, adding this one, deleting this one. Like that I will do in front of you. Automatically it will take the 4 to 5 hours of overall project. Now for 5 hours I will do in front of you only. Single project only will take 4 to 5 days. At the end, you should not tell me that, sir, when the course will end, by what time it will be completed. Don't ask these type of questions, because you want me to do whatever has to be done in the lab also. Here only you want me to do means automatically the time will increase. No, sir. After that, you just tell us what to do. After the class, we will try in the lab. We will execute that one. Miss, that is one way. Now here, what are the working professionals will be there, na? Who are the working professionals are there? All these working professionals basically will not have the time for doing the practice. No time for practice. So since they don't have the time for practice, what they want is, sir, do in front of us. Do in front of us. At the same time, same working professionals will ask when this course will end. Not freshers will ask. Only experienced people only will ask when course end. Why? Because immediately they have to apply for the new job and they want to get the more package. Everything has to be completed. That too, everything has to be completed in the short time only. And money has to come. Without time for the practice. Which indirectly I will call it as some kind of greediness. From my perspective. Right? So, here you require the time for the practice. Now, all the working professionals, what I'm going to say to you is, and of course, for the freshers also, after the class, from today or something, every day you have to dedicate the more amount of time for the creating the multiple models. Just by listening and whatever you are seeing, and today class was completed, again tomorrow's class, if you continue the same process, very less probability of getting the jobs in the market. Don't blame the market, don't blame the institute, don't blame the trainer, don't blame the subject, or don't blame anything. Just blame your time only. You are not having the time, so you have not got the job. Only blame this one. Okay? Don't blame outside market. There is no jobs presently. Presently, multiple jobs are there. Every day, multiple people are getting, and multiple interview calls are also available. Okay, yesterday, recently I have started explaining for you multiple times. Yesterday, one of the student has got placed. This one student has got placed. That one, this one I'm saying now. Of course, today there is no student. Example point. Okay. I don't want to lie. If I want to lie means I can say today also one of the student has got placed. I don't want to lie or something. Just here, take the time for the practice. Okay. Now here, this time for the, when I have done not in front of you, when I have done the same project separately, first I have tried with the 15 neurons only. After trying with the 15 neurons, I added one more layer with the 15 neurons. Accuracy was increased. So since accuracy was increased, what I have done is I have added one more layer also. Now again what happened? Accuracy was increased. Then I added one more layer also. Again accuracy was increased. Now what I have done? I have added one more layer also. After this fifth layer also I have added. Now suddenly accuracy was dropped. When I have added the fifth layer, accuracy was dropped. Now in this case, what I have to do? Remove the fifth layer. Not required. Now we are having only the 4 layers. Now in these 4 layers also, what are the 4 layers I am having? Okay. Now in these 4 layers, I am having the some kind of what we call it as overfitting problem. That is difference. So then what I have done is I have added the dropout. Dropout is used to reduce the overfitting problem. Since in my case I have observed overfitting problem is there. Now how many times I have increased the layers means till train accuracy increases. Till how many times the train accuracy increases, that many times I added the layers. till train accuracy increases. First I have tried with 1 layer, 2 layers, 3 layers, 4 layers, 5 layers, 6 layers. Till the accuracy increases, I also increase the layers. The moment when train accuracy drops, suddenly, then in that case, stop adding the layers. Stop adding layers. Like this, I decided the number of layers. It is pure trial and error method. Okay, it is pure trial and error method, guys. When train accuracy increases, I'm adding the layers. When train accuracy suddenly drops, I'm stopping the layers because there is no use of too much of examples will not have any use. After certain examples or something, we have to stop. After that, there will be no use. Now the train accuracy increases and we are going to add the layers. After when the train accuracy drop, stop adding the layers. Now for the last layer, what are the last layer we are added? Now I'm going to observe the test accuracy also. Now once the layers are locked, with these layers are locked. Now what I will do? Now I will observe. Now I will observe test accuracy. What are the test accuracies there? Just I am observing the test accuracy. Now if while observing the test accuracy, there is a lot of difference between the train and test, which we call it as overfitting, underfitting, either overfitting or underfitting, or good model. Three things will be there. If it is having the overfitting, then I will start reducing the overfitting problem. To reduce overfitting problem, I am having the two options. One is called as, the first one is called as dropout. Dropout. What is meant by dropout? Dropout means where you are going to drop the sum of the neurons. Okay, what are the number of neurons are there? Inside that number of neurons, you are going to drop the 20% of the neurons. 0.2. 0.2 means 20%. 20% of the neurons. Total how many connections are there? 50 neurons are there. Out of 50, it is going to drop 20%. 20% of 50 means 10. 10 connections will be dropped. Okay, 10 connections will be dropped. So this is one way of to reduce the overfitting problem. One way of reducing the overfitting problem is dropout. The second way of reducing the overfitting problem is reduce the number of neurons. Instead of 50, reduce the number of neurons. Go with 40 only. Okay, don't go with the 50. Reduce the number of neurons. These are the two options are available. So what I have done is I have added the dropout function. And after that, I have observed. See guys, first let me tell you like this. I have added the first one layer. Observe this one clearly. With the first layer, I got 70% accuracy. Which one? Train. By adding the second layer, I got the 74. Now should I add one more layer or not? Yes, I added one more layer. 79. Now should I add one more layer or not? Added. 85. Now fifth layer. Should I add one more layer or not? Added. Fifth layer. 82. Now what I have to do? Remove the layer. I have removed. With this, layers are locked. How many layers are finalized? Only 4 layers. Layers are locked. Now, which is not locked means neurons are not locked. Now, what I'm going to do in the test accuracy, I'm going to observe here. Here, the difference is 65-85. Test accuracy is only 65. Earlier, I have focused only on the train accuracy and it was increased. Now, when I observed, test accuracy was now 65 with the 4 layers. With the 4 layers, the test accuracy is 65. Yes, we are going to conclude the 4th layer only, up to 4 layers only. So the moment whenever the train accuracy drop, we have to stop updating the layers. Now I have observed the difference of 20% difference is there. Since there is a 20% difference between both of them, okay. Now what I want, I have decided is, okay, since there is a lot of difference between both of them, now overfitting problem is there. So I added the dropout. For which one I have added the dropout? Only to the 4th layer. I have not added for the remaining layers. Only for the 4th layer I have added the dropout. Now suddenly what happened is, it was increased to 67. Still overfitting only is there. It was not rectified. Now what I have done is I have added the dropout for this one also. Now suddenly this was increased to 72. Overfitting is there or not there? Available. Now what I have done, I have added the dropout for this one also. Now again this I have got the 80. Now when I added the dropout here, one more time I have added the dropout. I got the 76. Still overfitting problem is there or not there? Miss, still overfitting is there. Assume you got here 82. You got the 82. Now overfitting problem was solved? Solved. Sir, but unexpectedly still overfitting was not solved, sir. Though you have added the dropouts for every layer also, still overfitting is there. Now what to do? Means in this total number of layers, how many neurons you have considered in each of them? 50, 50, 50, something like this. Now you change to 40. Sir, by changing to this one to 40, the accuracy was increased to 78. Increased. Now what you have to do? In the third layer also, you will change to 40. Sir, no sir. By adding 40, from 76, it was dropped to 72, sir. Means overfitting increased. By decreasing neuron, overfitting increases. Means inversely proportional to each other. Now what I have to do? Increase neurons or decrease neurons? Increase neurons. Directly proportional means, for example, if I decrease, this is decreasing. Which one? Overfitting problem decreasing means still I will continue the decreasing. For example, what I am doing, opposite happening. What I am doing, opposite is happening means I will do opposite now. Then automatically for my opposite, it will do again opposite. So finally, actual answer I will get. Point is clear? Understood the logic or not? Yes or no? Everyone. So now here the number of neurons are 50 amma. This is 76. 50 neurons. 76. From 50 I have brought to 40. My test accuracy was dropped to 74. When I am decreasing the neurons, test accuracy decreases. Now from this, what you have understood? Increase the neurons. So now I am increasing the neurons to 16 neurons. My test accuracy was increased to 77. Now what I have to do? Increasing means automatically I loss increase now. Instead of increasing in the single one, increase is best, or adding in the different layers, increasing is best. Already I observed in the starting only now, increasing in the layers is best. So I will add here 60. And I will observe here 78. I will add here 60. Here I got the 80. I will add here 60. Here I got the 81. Sir, this is pure trial and error, no sir. These many times we have to modify and every time we have to observe miss. Obviously that is only same thing. For example, you tell me guys, you are having one radio with you. Okay. A radio with a knob. Do you remember olden days we used to have the radio with knob? Some of you have seen that one. Okay. Now everyone are having the auto FM. Whatever we are having in our mobile phones, it is auto tuning. It is tuning automatically. For example, if you are having the olden days radio is there and you are having one knob for that and you have to rotate. For example, you don't know what is the radio frequency where you are going to have the FM. You don't know what is the frequency. Now what you are going to do in that case? There is no Google, there is no other person, there is no contact or something. You and radio, only you both are there. Don't ask that I will check in the ChatGPT. There is no ChatGPT, there is no Google, nothing. I will ask other person. There is no person also. You are in the forest and you are only the person. Now what you will do in this case? Sir, first I will try with the 90. 90, who decided 90? You know 90, yeah? First tell me how you decided 90? Somewhere we have to start now. I also don't know it is 90 or 91 or 92. I also don't know. Somewhere I have to start now. In my brain, 90 I have started with the 90. I also don't know. Now I'm going to try with the 90.1. At 90.1, are you going to listen to the sound or you will not check? Just you will turn like that. 90.1 you will set. After setting to that, whether are you going to listen the output or not. What you are going to get from the radio, you will see that because it is giving the output or not, are you going to observe? Just you will change the value. After that 90.2, again you will observe the output. For example, there is no output from the radio. Then what you are going to try? 90.3. Again, there is no output. Every time you are going to observe the output, right? For every single value, you will observe the output, right? So in the same way, when I am doing the modeling also, for every one value change, I have to observe the train accuracy, test accuracy. Point is clear? So modeling and evaluation will be done simultaneously. Then you are going to change again one value, again you will observe the output. Output means what? In the radio, what is the output? Sound only is the output. What are the sound you are going to get from the radio? That is only output. Clarity of the sound. Right? Again, you are going to observe at 90.5 also it is not working. You are not getting nothing sound. What you are going to do in that case? Increase, right? Somewhere you'll get the some sound. Slightly you are getting the sound and voice also, but clarity is not there. What you are going to do? Increase, right? Same logic, guys. This concept we call it as tuning. Sir, nowadays why that radio is not there means in your mobile phone, it is doing automatically. In the back end while loop is working. Wherever the output is perfect output is there, break. In the back end while loop is working. It is doing the same thing in your mobile phone basically. In your mobile phone or in your car or wherever it is. It is doing automatically for that. Basically, it is also doing the same thing, but you don't know what is the code behind that. Internally, it is doing that one. Whenever the perfect answer is there, it is applying the break in the back end of the code. Automatically from one radio station to another radio station, if you observe, it will go from 93.5 to 93.6, 93.7, like that. It will increase the numbers and finally 98.3, again it will stop. How it knows that it has to stop there means in the back end the code was written. A perfect output is there means what would be the numbers. According to that, they have written the break. Points are clear, guys? Everyone? So same way, here we are going to apply the tuning. And after applying the tuning, and finally we are going to get the output. Now, my output layer, final output layer consists of only one neuron and automatically the activation function. Sir, what is the activation function? Means for LSTM, you don't need to write the separate activation functions like ReLU or sigmoid or something. Because already in the neuron itself, the activation functions by default available. You don't need to particularly mention that one like ANN. Point is clear? Understood? Yes or no? Everyone please confirm. How you decided is clear? Everyone please confirm me, guys. Now, number of layers, how you decided, number of neurons, how you decided. Finally, this one. Dropout means it is going to drop some of the connections. Whenever you have the overfitting problem, it is going to try to drop the sum of the connections. The more number of connections, more the complex of the equation. If you remember the polynomial regression, already the theory part of polynomial regression, as degree increases, what happens? Number of slopes increases. Now, if you decrease that in that some of them which are unimportant, we are going to drop them. Same way. Yes, we need to observe how many layers will give the very good accuracy. One after one, we have to try. Points are clear, guys? Everyone. Can we apply regularization in LSTM? Miss, here in the LSTM, we cannot apply the regularization. That logic is not applicable here. For overfitting problem, what are the L1 and L2 regularization we have discussed now, that will not be applicable. Sir, could you explain the picture as you explained in ANN? I want to see the working so that to execute the code. I'm not clear how it is working. Means just to draw the layer and show the data flows in the drawing, please. Okay. Now, so you want the diagram in the drawing. Okay. So here is the drawing as per the student, one of the student requirement. Prasad, just I'm going to show you the drawing. This is the one. So this only this one. If you observe this circle, this one, this one, this one, this one, this one. This is first neuron. First neuron to connection to the second neuron. Second neuron was connected to the third neuron. Can you see here? Obviously, this is the input. This is input. This is previous output. This previous output and this input was given to this, and it is going to give the output. Again, new input, the previous output. Along with these two, it is going to give the new output. Again, the new input like this. So this is one layer. What are the blue circles? On the back side, what are you seeing? There are the multiple layers. This is diagram of the multiple layers. Is that clear? This is one neuron. From here to here, one neuron. Second neuron. Third neuron. Like that, we are having the multiple neurons in a single layer, and these are the multiple layers. Point is clear now? The pictorial representation. Only difference is, since it is a RNN, neuron, so two inputs you are going to get, one output it is going to give. If it is LSTM, you are going to add the one more. That is long term. Long term will be added. That is nothing but cell state. Cell state will be added. The which of the information was stored in the cell state, it will be carry forward. Okay. Sir, how many units in diagram? Here, number of units in this diagram as of now, 1, 2, 3, and this is 4. This blue one, 1, 2, 3, and 4. In between dots are there. Multiple. So this is layers. First layer, second layer, third layer, fourth layer, fifth layer, sixth layer. Layers. These are the layers. Total 6 layers are there. Okay. If you want to say a single layer, this is the single layer. It is a single layer. Point is clear? Now, same way for LSTM. This is for RNN, single layer of RNN. Now, I want to see the single layer of LSTM. Okay, this is a single layer of LSTM with 3 neurons. Point is clear, guys? Everyone? Yes or no? Prasad, your question is clear now? Now, could you please mark down the reason why we are using this coding, sir? Which coding? Drop down. Drop down is used for to reduce the overfitting problem. Now, so this is the modeling. Modeling means where you are going to have the neural network. First design of the neural network. After design, as we know now, at the end we are going to fit the train data. That is fit on X train comma Y train, and number of epochs is equal to 100. So this is common. If you open the ANN code, in the ANN what we have designed, first design. After the design was completed, optimizer is equal to Adam. That is nothing but gradient descent. And the weight has to be updated every time based on the mean square error. Same code we have written even in the ANN. So this is common. Along with that, fit on X train comma Y train. Now the data is fitted and it is going to do the entire calculations. That is first initial weight it will be taking random weights. What are the random weights are there? It will take the random weights and later the weights will be updated. Like that it is going to continue. Now, next from here, what I'm going to do is as I required to predict on the future data, that is 1 month data now. So I'm going to load the text data. What the text data is there? I'm trying to load the text data here. After loading the text data, in this also similarly, I'm going to consider the single column. There also I have taken the single column. In training also single, here also single. And what are the single column is there? Directly, instead of predicting directly on that, first I have to do the scaling. So for that, what we are going to do? So again, I'm similarly, whatever we have done here, if you go back, here I have written the code now. The same code, what are this code is there? The same code I have used it there and I have converted the data. Now after converting the data, after converting from here to here, I have converted. Once I have converted the data, after converting, see here, first what I have done is transform I have done. What is transform? Because my test data consists of original values, that original values has to be scaled. To be scaled, I have used the transform. After transform, I will predict. After predict, what are the output is there? That output has to be converted to again original value. It is called as inverse transform. Point is clear, guys? Understood or not? Now here, what are the test data is there? Again, one more time, I'm showing you. So what are the test data is there? Now in this test data, I'm not going to consider the remaining columns, only one column. Okay, first, this is my first step. What are the single column is there? I'm going to consider the single column. Now here the big numbers are there. First I have to transform this. Okay, to convert. So should I calculate the fit and transform or only transform on the test data? Should I apply fit on test data or no? Yes or no? On the test data, should we apply? So answer is no. So here what I'm going to do, transform. Transform is whatever was calculated already the minimum values and maximum values in the trained data, I will use them and I will transform the values like this. For example, this value was transformed to 0.07. This value was transformed to 0.92. Something like this, it will be transformed. Now, what are the transformed data is there? Some values will be there now. What are the transformed values? Let's take an example like this. Okay, now these transform values, I'm going to give to the model.predict on the data. Now, when it is predicted, it is going to give the some output. What are the output it has generated? For example, it has given the output as 0.4. Now, this 0.4, again, I'm going to do the inverse transform. After doing the inverse transform, now here I got the some 770. Now, what are the 770 is there? This one, I'm going to compare with this one. Is that clear now? Everyone? Yes or no? Now, Vidyasagar, what is the use of LSTM in this case? When there are other regression algorithms are available for prediction? Sequential order. What are the regular regression algorithms we are discussing in the ML versus ANN? These are all works on the cross-sectional data. LSTM specialty is sequential order of the data. Right, guys? So just I'm going to share you the code along with the, yes, here if I execute this one, it will take time for fitting. This one is not a problem. To create this one, this is not a problem. And this is also not a problem. Creating the layers, what are the layers are there? All these layers will be created and compile also will be done. And when we apply the fit on X train Y trainer, it will take almost 30 to 45 minutes of time to calculate. This single line of code, it will take almost 30 to 45 minutes. So just try to execute from your end. Can we test with the simple data like a small data set? Even 100% you can try. Yes. In that layer, you want to drop now. For example, here 15 neurons you want to drop. So wherever you want to drop that one, there you have to add the dropouts. If you want to drop in this layer, miss, add here dropout. If you want to add here some dropout, miss, add here. Wherever you want, there you have to add the dropouts. Okay, in every layer you may not apply the dropout. Na? In only one or two layers you may have the dropouts, maybe in some cases. Yes, here what are the this code and that code both will be the same. Whatever I have explained now, right now, the same code you are going to see here. Okay, just I'm going to upload in your drive. Just you can open and check right now and you can confirm me. How do we understand we need to drop out? Already I have explained that one, right? In which case you have to apply the dropout. In the sequence, whenever you find the overfitting problem, Ganesh, sir, why we are doing it before calculating RMSC? Which one? Which one we are doing that one before RMSC? I didn't understand your question. Dropout, huh? Why we are doing? Yes, as I've told you now, earlier what I have told you. First, I will take the first model and I will apply. Second model, I will apply. For every model, I have done the same. Whatever you are seeing is the final answer. Whatever you are seeing on this here now, total 4 layers are there for each of them, point two, point two, point two. This is the final answer. But when we have done the first one, na, first one we have done with the after fitting on this, we have calculated the RMSC also. How to calculate the RMSC? Here, once we have predicted the values, what are the predicted values we are having? And we are going to calculate the difference between the actual values versus predicted values. Use the difference between actual values versus predicted values. That is nothing but RMSC, RMSC and MSC. Done. If anyone has any questions, please ask. Once I have uploaded the code, please execute from your end. And please confirm me tomorrow only what you have observed. And while doing the code also, directly don't add as is my code. First, you try with the only one layer with 50 neurons and calculate the train RMSC, test RMSC separately. And from that, you go with the second one. Again, calculate. Like that, you have to apply the multiple models tomorrow. Once I upload the code, please practice this. Done. Yeah, others, if you're not having any questions, you can leave.